transition, my friends, a demographic transition that is, of the demographic study of people's transition or change over time, transitioning from something to something else. And the demographic transition model is a lovely little theory which helps explain the structure of a population and the population totals as they change over time as societies evolve. And I'm going to keep evolve in quotation marks here because it is the grand assumption of this theory that you need to buy into. And the assumption goes something like this, that all states or societies on planet Earth want to evolve from a backwards-ass, undeveloped status and go through some sort of agricultural industrial revolution and end up on the other side as a post-industrial, fully developed, rich place. That's an assumption worth buying into, I think. If you went around the planet and asked people, hey, would you like to live in a completely undeveloped poor place, or would you prefer a fully developed rich state? I think most people would choose the latter. How about you? So it's a theory worth investigating further, even though it has its faults that we'll point out later. Now, before we get to the model itself, we need to investigate some key terms, some inputs that go into the model, as well as some of the outputs. The first things first, if you're going to identify and talk about the population of a state, you need to know how many people are coming into that population every year. The birth rate, that is how many babies are being born into the society every year, and this is a rate, it's per 1,000 of the total population. Example, the United States birth rate is 14. 14 new babies are born per every 1,000 people in the United States every year. Now again, let me stress, this is a rate. It's not a total. It's not 14 total. It's a rate per 1,000. To help you understand this, China's birth rate is exactly the same. Both countries have a birth rate of 14. But the United States only has 300 million citizens. China has 1.3 billion. So you can quickly do the math here and see that while both are having 14 babies per 1,000 people, there's a hell of a lot more babies being born in China every year than the United States, because you got to multiply that out to the 1.3 billion citizens they have. To look at some other extremes of birth rate around the planet, the Japanese birth rate is only 7. It's a very low birth rate. Only 7 babies born per every 1,000 people in the population every year. In the other extreme, Uganda in Africa, 48 babies born every year per 1,000 of the citizens in that state. Man, they're getting busy in Uganda. The alternative side of this spectrum, when you're looking at a population, is the death rate, of course. How many people are being sucked out of the population every year? It's expressed as a rate per 1,000 as well. The United States death rate is about 8. 8 people die per every 1,000 people in the United States every year. China, roughly the same, 7.5 or 8. In the United Arab Emirates, the UAE, only 2 people die per year, per 1,000 people. That's a really great place to live. Nobody dies there. A much rougher, tougher place to stay alive is Afghanistan, where, by and large, a lot of people don't. 20 people per every 1,000 die every year in Afghanistan. It's a tough place. Other demographic descriptors of note that we will talk about throughout explaining this model: infant mortality rate. That is how many babies will not live to their first birthday per every 1,000 babies born that year. In Japan, it's only 3. Only 3 babies per every 1,000 born every year will die before their first birthday. In the United States, it's double that, 6. It's still a pretty low number. 6 babies die every year per 1,000 born. India, 30. 30 babies are going to die before their first birthday. And in Angola, 180 per 1,000 babies born will not live to blow out their first birthday candle. Wow, tough place to be a kid. Next demographic descriptor of note, longevity or life expectancy. At what's the average age that people will live to or die at, whichever way you want to look at it. In Japan, 82. The average age at death is 82. Means a lot. Some people live a lot longer. Some people not as long. Average 82. In the United States, 78. In Bangladesh, 60. Whoa, numbers are getting lower. And let's go back to Angola. It ain't fun to be a baby there. It's not as much fun to be an adult either. Average life expectancy in Angola, 38. Wow, I'd be dead already. That's a tough place all the way around. The last demographic term to know is fertility rate. Fertility rate of any state is the average number of babies that every woman in that state will have over the course of her entire life. It's not per thousand, it's the average number of kids that each woman has over the course of her entire life. In the United States, the fertility rate is 2.1. The average U.S. woman in her life will have 2 kids and an arm, the 0.1. That's actually a very important number. We'll come back to that in a second. In Japan, the fertility rate is 1.3. So they only have, on average, every woman has 1 kid, and 0.3. In India, women have, on average, 3 kids in their life. In Saudi Arabia, 4 kids. And let's go back to fun times Uganda. The average woman in Uganda has 7 children in her lifetime, and that's an average, which means that there are a lot of women who don't have that many kids, meaning some are having a heck of a lot more. Fun times. Now, let's go back to the U.S. I said that 2.1 fertility rate was extremely important, and it is. It's so important it has a term attached to it called replacement level. And what that means is, little sex ed 101 here. For babies to be born, you got to have a woman get together with a man. They get together and procreate. Luckily, they still need us for this, gentlemen. And when these 2 people from society get together, if they have a fertility rate of exactly 2.1, that means they have 2 kids. And that when mom and dad get old and die, there are 2 kids left who are replacing them in the population. Does that make sense? And then those 2 kids will go off and get married and have 2 kids. And when they die, they've replaced themselves. So the same number of people are coming in to the society as are checking out. They've replaced themselves. In this scenario with a fertility rate of 2.1, the population total never gets any bigger or smaller. It's stable. Dig? Now, before anybody asks, what's the 0.1 all about? Why is it 2.1? The 0.1 accounts for kids that live past their first birthday but don't make it to the procreation age. So kids, a 10-year-old that gets hit by a bus or overdoses on crack or whatever. That is the kids that don't quite make it there. You bump up the average a little bit to keep that round number in so the population totals stay the same. 2 people in, 2 people out year after year. You can tell a lot about any society just knowing that fertility rate. Because if it's lower than 2.1, that means the society's getting smaller every year. So in Japan, 2 people get together, they only have 1 kid. So when mom and dad die, there's only 1. And then 1 kid goes and finds another kid, and they get together, they only have 1. Every year, the population will get smaller. It's shrinking. The inverse of that is in Uganda, where the fertility rate is 7. So 2 people get together and create 7 more humans. The population overall will be exploding or getting much bigger. So knowing that replacement level and the fertility rate of any place tells you a lot about what's going on. Now, we've covered all the rates, the inputs, the outputs. Let's look at the model itself now. The demographic transition model breaks this societal evolution into 4 nice, tidy stages based roughly on what's going on in the society at the time, what are people doing for a living, and therefore what do they think about family size, and therefore how does that affect total population. I'm actually going to throw in a stage 5, but I'll leave that as a surprise for later. Now, looking at the graph, you see that on the y-axis, we have these rates, and the rates of particular note are, of course, the birth rate, which we'll show in blue, and the death rate, which we'll put in red. And I'll get the y-axis, rates per thousand, 10 per thousand, 20 per thousand, 40 per thousand. And the x-axis is showing over time. You're going from someplace in the past, over time, how a society will evolve. And let's just go ahead and jump in with both feet and jump into stage 1.